Hello everybody, my name is Dang Shao Kao. Currently a cloud engineer in Viettel High Technology, Viettel Group, and a master student at Hanoi University of Science and Technology in Vietnam. For ICAST 2023, my team are very glad to present our research named Analytics Autoscaling Architect in Telco Cloud. I will present this in the following sections. First, I will introduce the purpose we want to achieve. Then, I will share our related work and our contributions. In the third part, I will introduce the design architect to solve the problem. Next, I will give the two algorithms we used. And finally, summarizing and providing future tasks will be done. First of all, I start with the background of the paper and the introduction of the topic. First, we need to distinguish some terms for the further to understand. Above virtualization, use software to divide the whole CPU, RAM, and HDD load of a computer into many VMs, virtual machines. The term cloud is known as a network of virtual machines developed according to the private, public, and hybrid models, which cloud natives is an approach to packaging and deploying applications on a cloud environment, including microservice design, container packaging, and CI/CD. About NFV is a standard for managing and controlling VNFs with network function in cloud environment, and at the end is used software to define network communication between VNFs. In the figure, the evolution of cloud native stack when using technology from virtualization to cloud and from now cloud native. Next, we talk about VNF virtual network function. We must know about virtual machine (VM), which is a computing resource that uses software instead of a physical computer to run programs and deploy apps. VNFs virtual network function are virtualization network service running on open compute platform, formerly carried out a proprietary dedicated hardware technology. Most VNFs are run in virtual machine VMs. Then we must talk about VNF virtual network function. But now we must be know about container and Kubernetes. A container is a standard unit of software that packages up code and on its dependencies so that applications run quickly and reliability from one computing environment to another. Kubernetes is a container-based deployment platform with many benefits, such as elasticity, durability, easy management, and cost-effectiveness. Cloud-native containerization is replacing virtual machine VMs as a preferred method of application deployment. However, the network requirements involved, including high performance and low latency, prove proved to be a barrier to deployment of 5G application. Cloud-native network functions (CNF) enable network functionalities to run in containers instead of traditional bare metal servers. Basically, virtual network function (VNFs) are software applications that deliver network functions such as directory service, routers, firewalls, load balancers, and more. They are deployed at virtual machine (VMs) and have often been The next step for telecommunication providers in their digital transformation from the physical network function (PNFs) of latency network appliance on proprietary hardware as an evolution from VNFs, cloud-native network function (CNFs) are designed and implemented to run inside containers. This containerization of network architect components makes it possible to run a variety of services on the same cluster and more easily on board already decomposed application while dynamically directing network traffic to the correct ports. Telco Cloud. Telco Cloud represents the data center resources which are required to deploy and manage a mobile phone network. Telco Cloud are based in private data center facilities, which are used to manage the telecommunication requirements of 3G, 4G, and LTE networks. With the current rollout of 5G equipment across the mobile service provider, vendors have adopted strategies related to network function virtualization (NFV) and software-defined data center (SDDC) management, which have become indispensable part of a telco setup. The current telco cloud architecture uses NFV architecture proposed by the European Telecommunication Standards Institute (ESC). It consists of virtualization network function (VNF layer), NFVI infrastructure (NFVI layer), operation support subsystem (OSS layer), and management automation and network orchestration (MANO layer). Auto-scaling is often referred to in the context of resource provisioning, scalability, and elasticity. These terms are often used interchangeably, but they are slightly different concepts. Understanding the difference between these concepts can help us to identify the unique issue of auto-scaling and focus on the solution. In its reference, the key features are the ability to scale out and scale in. Scale out is the assemble the automatic arsenal of extra resource during increased demands, and scaling example is the automatic terminating of extra unused resource when demand decrease to minimize cost. Choose the capacity of setting rules for scaling out and in. 3. The facility of automatically detect and replace unhealthy and or unreachable instance. Now I will quickly go over previous contributions made by other authors and how our research. In the first related work, C.Chiu et al. Proposed a useful architecture for dynamic scaling of web applications in a virtualized cloud computing environment. The architecture includes a load balancer, virtual cluster orchestrator system, and an auto-provisioning system, and work efficiently in virtual machines. However, a user can run many virtual machines to perform his applications, which are not only web applications. Meanwhile, for security, virtual machines for a specific user can be regarded as a group, and a user cannot access the resource from other groups. Then, Chelun Hung as or a dynamic scaling scenario with a novel design of application deployed in virtual machine in a virtual cluster. But the architect thus applies to the application running on a virtual machine. The use of containers as a base technology for larger scale system open many challenges in the area of resource management at runtime. Based on container technology, E.Casalicio and V.Percibali address the problem of selecting the more appropriate performance metric to activate auto-scaling action. In the figure, the high-level architect of the auto-scaling controller in Kubernetes. Related metrics are collected by C advisor. Absolutely, metrics could be collected at hot level, virtual machine, and or infrastructure level, physical machines. Our contributions. We aim to introduce an elastic auto-scaling architect for application deployed in virtual machine and on the port in a Telco Cloud, and to provide two algorithm about auto-scaling used. As a result, we were integrated with Telco Cloud for online charging service application, serve more than 1 million customers and is expanding. In the next session, I will give you an overview of the architect design in our Telco Cloud. A scalable architect that effectively handles the two scenarios is illustrated in the figure. This architect includes three main components: lo- a load balancer, management and orchestrator system (MANO), and an auto-scaling system with two auto-scaling algorithms. The load balancer can balance the requests between different virtual machines or pods that perform the same application in a virtual cluster. Management and orchestrator systems used for management VMs on OpenStack or pods on Kubernetes collect resource use or other attributes of own VMs and pods for each virtual cluster that is running on the cloud. The auto-scaling system with three modules in it includes a load balancer controller, a REST collector, and scaling management plugin. It can horizontally expand, shrink the number of VMs and the number of ports according to the workloads of a virtual cluster over mono where VM's ports belong, and the new one can serve service. If the application running on the virtual cluster consumes most of the resource or is over a defined threshold, the auto-scaling system can create a new VM or new pods that perform the same application and load balancer and then balance the request among VMs or pods in the same virtual cluster. In our architecture, the load balancer is enthused to balance the telco application load depending on the way we deploy application on virtual machine or pod. Kubernetes. We choose the appropriate load balancer. When deploy an application on a virtual machine, Apache HTTP load balancer is used as a load balancer to allow incoming HTTP requests to be routed into servers that perform the telco application. Since the Apache HTTP load balancer configuration can be updated dynamically, This allows a cloud system to automatically and dynamically add new servers for a virtual cluster. The West server enables the virtual cluster to scale and to provide better response time for incoming HTTP requests. I'll deploy an application on pod Kubernetes. We use Kubernetes load balancer. You ask a load balancer to allow incoming HTTP requests to be routed into bots that performs telco application. With the configuration of Kubernetes load balancer can be updated dynamically and a cloud system to automatically and dynamically adds a new port for a virtual cluster. The additional ports enables the virtual cluster to scale and to provide better response time for incoming HTTP requests to the system. The, man, the MANO system is a platform that supports the management of cloud infrastructure, management and deploy of CNF, VNF, 4G and 5G core networks on the cloud infrastructure. In particular, Mano manages the physical server of cloud infrastructure through Kubernetes and OpenStack. Many services deploy in the form of VM through OpenStack and service deploy as cloud native through Kubernetes. The Mano system includes front-end, back-end database components and agent collecting, monitoring, and controlling the component of cloud like NFVI, VIM, and CNF VNF platform. Scaling management plugin is a support system for auto-scaling our application for the virtual cluster. With the architect in the figure, it has three components. API is a RESTful API for a third-party component to work with this plugin. Rule management is a rule engine for manual rules you provisioning modules which run based on rule can detect and replace the instance with stated unhealthy or unreachable. Now I will show two algorithms we used for our cluster. With a defined threshold, we illustrate our auto-scaling algorithm on algorithm 1. When telco service run on VM, the algorithm first determines the current VMs with the resource defined in the rule above or below given threshold numbers, respectively. If all VMs have resource defined in the rule above the given upper threshold, a new VM will be provisioned, started, and then added to the load balancer, respectively. If there are VMs with resource defined in the rule below a given lower threshold and with at least one VM that had no resource defined in the rule, the idle VM will be removed from the load balancer and terminated from the system. For Telco service running on post Kubernetes, which the rule defined may be about physical computing resource, such as the use of CPU and memory, will be indiced for the evolution of the workloads of a virtual cluster. When telco application running is if the use of the resource of some pods are below a given low threshold and with at least one pod that had no computing job, the idle pod will be terminated from the virtual cluster. With the requirements of telco service, the customer will use more resource with specific time on area. Then the telco service should scale in and scale out application serve for that time. We provide an auto-scaling algorithm that allows scalar scale application at a specific time that is illustrated in algorithm 2. I will now proceed to the end of my presentation by discussing some potential future works. We have presented two scaling scenarios to address the automatic scalability of telco application on VM and on Kubernetes in a virtual cluster on the virtual cloud computing environment. The proposed cloud computing architecture is a construct with a load balancer, a management and orchestrator system, and an auto-scaling system. The load balancer is used to route and balance user requests to cloud service deployed in a virtual cluster. The management and orchestrator system is used to collect the yield of physical resource and define attributes for of its virtual machine or exports in a virtual cluster. The auto scaling system with scaling management plugin is a tool to dynamically provision the virtual machine and ports based on the rule user define or the yield of the resource in the virtual cluster. In Arsenal, idle virtual machine or ports are destroyed and then the resource can be released. On the other hand, the energy cost can be reduced by removing the idle virtual machine and ports. Our architect has demonstrated the proposed algorithm for Telco Cloud are capable of handling suddenly lots requirements, maintaining high resource utilization, and reduce energy cost. The scaling management plugin of the autoscale system is an essential element in enhancing resource utilization to reduce the infrastructure and management costs. In the future, besides VNF and CNF, we will extend support applications running on bare metal and more, and where we use other algorithms or improve existing algorithms to accommodate the auto-scaling application. Here is a reference list from this presentation. Thank you for your attention. Feel free to give us any comments or questions. Thank you.